When we think about life on Earth, we usually picture ecosystems driven by a single, massive engine, the sun. Photosynthesis builds the base of the food chain, and sunlight dictates almost everything about how animals move, hunt, and survive. But that sunlit layer is actually a tiny fraction of our planet's habitable space. If you calculate the total sheer volume where life can exist on Earth, roughly 99% of it sits in permanent, total darkness. Drop just a few hundred meters below the waves, and the solar energy that powers the surface world completely vanishes. The warmth dissipates, leaving waters that hover just above freezing. This chart illustrates the hostile reality of a deep ocean descent. Down here, the environment imposes three unyielding constraints: absolute zero sunlight, near freezing temperatures, and hydrostatic pressure hundreds of times greater than what we feel at sea level. You might expect an environment with those parameters to be a sterile wasteland. Instead, the total absence of solar energy acted as a harsh physical filter, forcing organisms to completely tear down and rebuild the biological rules of survival. Looking at our depth map, the first distinct layer of this extreme environment begins as we slide down the continental slope. This is the mesopelagic, or twilight zone, stretching down to 1,000 meters. In this zone, solar energy is so scarce that a single stray photon is highly valuable. Animals here have to engineer extreme, hyper-efficient ways to capture whatever faint traces of light filter down from above. Curious, take the barrel-eye fish. To solve the problem of light scarcity, it developed a transparent, fluid-filled dome for a head, protecting two massive, bright green lenses that point straight up. These internal structures function like biological telescopes. They gather and focus the last dying glimmers of sunlight to silhouette potential prey swimming overhead. Surviving the twilight zone requires organisms to stop fighting the darkness and instead build highly specialized anatomy to exploit an environment of absolute scarcity. Continuing our descent down the chart, we cross the 4,000-meter mark and enter the bathopelagic, or midnight zone. Here, the sun's influence drops completely to zero. Without a star to illuminate their surroundings, many creatures down here rely on bioluminescence, a chemical reaction that allows them to generate their own internal light. In a massive, empty void where meals are rare, predators weaponize this chemistry. The anglerfish dangles a glowing beacon from its head to attract curious prey directly into its jaws. But bioluminescence is equally effective as a defense mechanism. Certain species of translucent shrimp vomit bright blue clouds of glowing liquid to blind or distract their attackers, buying them crucial seconds to escape in the dark. When an ecosystem is entirely cut off from external energy, biology adapts by turning the animals themselves into localized sources of light and power. Eventually, the ocean floor drops out entirely into the Haddle Zone. This chart marks the very bottom of these trenches at nearly 11,000 meters deep. The pressure here is enough to crush titanium. The trench floor is a vast, desolate expanse of mud and rock where fast-moving prey is virtually non-existent. This is where we find the tripod fish. It survives by becoming the ultimate master of energy conservation. Instead of burning precious calories swimming to hunt, it uses long, rigid fin extensions to prop itself up above the mud. It simply stands perfectly still, acting as a living, zero-energy net waiting for the slow current to push tiny crustaceans into its mouth. At the absolute maximum limits of hydrostatic pressure, physical exertion is a liability. Radical hyperefficiency and absolute stillness separate the organisms that survive from the ones that perish. Zooming out from these individual species, the deep ocean reveals itself as a massive, thriving network of extremophile bioengineers. This entire ecosystem forces us to reconsider the strict biological boundaries we place on habitability. It proves that complex life can flourish indefinitely without ever seeing a star. That realization has massive implications for astrophysics. When scientists look at the cracked, red-veined ice skyling Jupiter's moon Europa, they suspect a vast liquid ocean sits beneath it. Because of what we found in our own abyssal trenches, astrobiologists have a working blueprint. The bioluminescent predators and energy-conserving bottom dwellers of the Haddle Zone show us exactly how extraterrestrial life might operate in the pitch-black waters of Europa, We spend billions sending probes into the void to search for alien ecosystems, but deep ocean biology suggests we are already living right on top of one. Welcome to the alien world of Noctiluxa.